All right, I have it 3:01 Eastern. We are going to get started with Steve. Here we are again, like I said, 4th out of 4 sessions. These will be posted on the learning roadmap. We will try to get everything put together, the PowerPoints as well as the recordings, into one area in the Learning Center so that you guys will have access to all these recordings as well as Steve's PowerPoints. So I will turn it over to Steve Solwin.
Thank you, Karen. So unlike last session where we were pretty much did death by PowerPoint, today I'm going to do a little thing different. We'll cover some PowerPoint, and then I've actually got the GUI up and running. So we'll actually do and go to the GUI and practice some of the stuff we talked about, so I can give you some hands-on experience, or at least a look at hands-on experience. We're going to start with performance. All right, first thing I want to talk about is just the performance aspects, right? Response time is one of the big things. I/O size is also important. Talk about IOPS per second and also throughput or bandwidth in megabytes or gigabytes per second. And a lot of times when we talk about performance, we'll have charts, right? And what I'm showing here is for the A9000R, it's for a full rack, 6-grid element rack, and it's a 70/30 4K. So it's a 70% read, 30% write, 4K I/O size, and then random miss. So basically what we're looking at here are some numbers that are a pretty ugly workload, right? A random miss means I'm not getting a lot of use out of my cache. I'm missing the cache. And for one, it doesn't look like a typical chart, right? There's kind of a slope here before we start to see the knee in the curve. But a couple things I want you to look at over on this side, right? We're looking at, we started 0.5 microseconds. We're starting at 0.5 milliseconds or 500 microseconds. But look down at the bottom here. We're starting at 186,000 IOPS. And then we're going out here and we're up to 2 million before and we're approaching the 3 millisecond response time. But a lot of customers won't run 180,000 IOPS on a single box. In fact, we probably have some customers that run 180,000 IOPS across multiple boxes. So that's just to point out some of the differences in the performance that we see on some of these flash systems, and that they are capable of handling. Excuse me while I close my door completely here. Capable of handling a lot more from an IOP perspective and still maintaining a very, very low response time. And this is, this is the worst case. I'm not taking any advantage of cache, so which is why I'm starting at a really high number, 500 microseconds. And I'll show you some more numbers in a little bit. But I expect to see, and I've got 1203 code is out now. I've got 12.1 code coming out early June. And I expect to see, have charts like this for a number of different workloads. Further on in the presentation, I mentioned Disk Magic. There's a tool that we can use to quantify, to create a workload and then run that workload or model that workload against a configuration. And that's and then the sort of what happens is the information we get from the performance team, which is where this chart came from, goes into the model that goes into Disk Magic so that we can run those numbers and get at least an estimate of the performance of that particular configuration against that particular workload. And again, we like to look at things like maximum IOPS, maximum bandwidth, and put together a workload that is maximum in both cases, so we can just make sure that, and typically we don't see that, right? Typically we don't see a box hit maximum throughput and maximum IOPS at the same time because they're typically characteristics of different workloads. But we like to put together the model so that we're covering the maximum in both cases, and typically maximum plus a little bit in both cases, to make sure that we've got adequate performance in any case and also obviously room to grow. So looking at some of the numbers for the 9000R, again, I've got the GA level numbers and the 1203 numbers. 1203 is the currently shipping code. We shouldn't have any box, again, Karen said they're just starting to show up in your guys' accounts. So there should not be anything but 1203 code on those boxes, because that's been bipped in the line and that's coming out of manufacturing. But again, looking at some of the changes, right, a read hit 4K, again, this is probably the best case number, but this is all cache hit. Not necessarily indicative of a real workload. But you can see that the numbers that have changed, right? 3.2 million up to 4 million on a read miss at 4K, 1 million up to 1.9 million. So I'm almost doubled right there, from 1 million to almost 2 million. The write hit stayed about the same. The write miss again increased a little bit. Now in the next couple workloads, we're looking at ones that are a little bit more indicative of what I call real workloads, right? I've got a 7030 4K, and then I've also got a 7030 with a hit percentage, with a cache hit percentage as well. So if you see a 7030 4K, right, that's reads, writes, and I/O size. Sometimes you'll see a 7030 50 or a 7030 80, and that's again read, write, and then cache hit percentage. Sometimes in some of the numbers for the A9, you'll also see 4 numbers here. You'll see a 7030 80 80 or 7030 50 80, and that last number is temporal locality, which essentially has to do with how effective the real-time compression engine is at allowing us to get better usage of the cache by pulling out information and essentially prefetching information that is related to other information from a time perspective. We've done some changes to the code to kind of minimize our reliance on that. We found out that we needed to be a little more what I call surgical in looking at information. So I think the latest numbers don't have that temporal locality reference in them, but some of the earlier numbers for the A9 did. But again, we've done some partial prefetch and partial extraction from a compressed object to kind of minimize our reliance on the temporal locality. So what you can do, again, this is a full rack. So this is a 6-grid element rack. And again, a better way to get an estimate is to use disk magic. But you can just, divide this by, do a straight mathematical reduction, because it scales fairly linearly from a 2-grid element to a 6-grid element. So if you've got a customer that wants a 4-grid element, you can do the math and divide this to the appropriate amount to get your ideas for what the performance is going to be for a 4-grid element or 2-grid element. Again, better is to model the workload in disk magic and get it, and then work it against a specific config in disk magic to get a better answer. But at least this can give you a kind of a thumb in the wind answer. Now, the latencies down here are, again, we see that for they either just stayed the same or went down. Do not associate these latencies with these numbers, because that's not what's happening. This is a single I/O latency, so this is a best case latency, and this is the highest IOP number. So please don't make the mistake saying, oh, I'm going to be able to do 4 million IOPS with a 50 microsecond response time. That simply is not the case. So this is more of a expected for a single I/O response time, and this is the maximum numbers I can do. Again, like you go back to the chart we were looking at, and we were looking at numbers that were 2.3 million and up almost to 3 millisecond response time. So again, just want to, they were put them here for reference purposes, but please don't assume that they go together. And then here are some numbers for the pod or the A9000 as opposed to the A9000R. Again, I've got fewer storage controllers, fewer. I've got less hardware in the grid controller. I've got 16 cores versus 20 cores and 192 gig of memory versus 384. So there are some physical differences in the hardware between the 9000 and the 9000R, and then obviously there's just more pieces of hardware in the 9000R. So that's why I see a fairly marked difference in the performance numbers, just because for one, the sheer number of grid controllers and storage enclosures I have in a full-up rack, and then also to some minor extent the differences that I have in the grid controller between the pod and the rack. So now kind of a more general discussion about performance, right? It is very application dependent. It can be very time dependent. Most customers have heavy work times and light work times. There are some boxes I see that stay pretty constant. One of the advantages of the grid, right, is I get very consistent performance. I may not get the best performance, but I get very consistent performance across a wide variety of workload because of the grid is able to focus the resources on active I/O. I'm going to see a difference, right, in write versus reads. For the A9, most of the writes are going to be straight into cache, and then we'll acknowledge the host when it's in cache in 3 different modules. Whereas reads, I have a much higher chance of missing what's in cache and having to go down to the storage for my reads. Sequential I/O is typically associated with larger blocks, and we talk about with the throughput numbers again, megabytes or gigabytes per second. And then random I/O is associated with IOPS, and again, it depends on I/O size. Like for the flash stuff, the I/O size isn't as important. I've got that coming up in a future chart where my small block size all looks about the same, regardless of whether I'm 2K, 4K, 8K, or even in some cases 16K I/O size. Now, in general, I am seeing I/O sizes get larger, right? Before we talk about 4K or 8K is typical now. I think 16 to 32K is more of a typical number. So again, looking at read hit, it's better if this is high. Again, I want to satisfy it from the A9000 cache. We talked a little bit about upper and lower cache in one of my previous discussions. So I'm going to get a read hit number regardless of whether it's coming out of upper cache or lower cache. I don't distinguish in my statistics between an upper cache hit or a lower cache hit. A read miss, obviously I'm missing both caches and having to go to the device. And then we talked about the characterization of the workload with the reads and then the writes and then the cache hits. Also sometimes the temporal locality reference number there as well. So one of the things that's important to remember when you're looking at either XIV or A9, essentially looking at something with a grid architecture, right? You want to make sure that your volume, your host is seeing every interface module or grid controller. And again, we'll talk about specific zoning characteristics or ideas for the A9 in a little bit. And then also I do want to do a smaller number of larger volumes. Lots of other storage, especially RAID-based storage, you can see where you've got to have a higher number of smaller volumes because of the RAID set underneath and limitations of the RAID set underneath. I don't have a RAID set per se in the grid architecture. I mean, technically I do have a RAID set underneath the partitions in the FS900s, but I'm still using that grid architecture to take those partitions and place them across all the resources of the grid. So I don't have that limitation, even though I do have RAID underlying and protecting the data. The other thing is the larger the volume, we actually get a little bit more efficiency out of the read ahead. So again, larger volumes are better. And I mean, the biggest thing with larger volumes is it's just less to manage. Right? If I can do, you know, 2 10-terabyte volumes as opposed to 10 2-terabyte volumes, I've got a lot less work to do and a lot less to manage. And I'm really not going to see a performance difference because in any case, all of those volumes are spread across all the resources of the grid. So again, a little bit about the building blocks I've got in the 9000. I've got my grid controller, which is a modified 3650 M5 with the dual sockets and the RAID 1 for the boot device and the 2 SSDs, as well as the hardware compression offload engines. And again, for the flash modules and FS900, they are always fully populated. For the 9000, I offer 12, 29, or 57. For the 9000R, I only offer the 29 or the 57. Here, again, are some numbers. Here, the basic effective capacity for the 9000. Again, that effective capacity is based on a 5-to-1 data reduction ratio. I see a max IOPS again. Don't associate the max IOPS with the minimum latency. Just saying I can do up to 500,000. I can get as low as 250. I can get lower than 250 actually for certain read hit workloads. But an all read hit workload is pretty atypical. Now the bottom numbers here are actually not the 900 numbers, but I leave them here for a very important point. You look at the number of random reads I can do across this box, and it's the same regardless of my capacity point. I look at my 70-30 random reads, and all of a sudden I see a very large difference. I see a random write, and again, see a very large difference when I'm looking at the smaller box. The way we build the micro latency modules in the FS900, I actually have 1, 2, or 4 chipsets, flash chipsets on each micro latency module. So the minimum config is a much reduced resource set from the maximum config. I have 4 times as many cards for the max config and 2 times as many, not cards, excuse me, chips for the middle config. So I do see potential performance differences in the A9000 based on limitations for the smaller FS900. Now, while I do see some performance differences between the 57 and the 29, again, this is TB bytes, not terabytes. I do not typically see that performance surface through the A9 because there are other factors in the A9 that mitigate that. But I can see and have seen the performance restrictions of the 12 terabyte 900 be the limiting factor for the overall pod performance when I'm dealing with a 12 terabyte 900. So again, just want to let you guys know that that's out there and to be aware of that. Let me just build this out. See, as I'm building out the grid elements and changing the numbers, I'm just going to build out and show everything all at once. So again, here are my grid elements, which are 2 grid controllers and 1, I should be pointing to the bottom one here because we start at the bottom and work out. 2 grid controllers, 1 900 in a grid element, minimum of 2 grid elements, so that's 4 grid controllers, 2 flash enclosures, and then I grow by grid element. And again, with the 1203 code, we have the ability to MES starting at 2 and growing up to 6. I believe that most of the boxes you see are going to be 3 grid element boxes, and then in odd cases we will actually be able to do MESs or get larger boxes. But I think the default for you guys that's been picked by Jim and his team is a 3-grid element configuration. Again, same change between effective, right, physical or usable capacity and effective capacity based on that 5-to-1 data reduction. Again, based on data, customers' mileage is going to vary, and when we go and start looking at the GUI, we'll talk a little bit about projected system capacity and where we make some changes to make the projected system capacity line up better with what is actually going on. Again, because the default number for that projected system capacity is 5-to-1. That may happen in some cases. Average is below that, so we'll need to make some changes to make sure we are projecting the correct capacity so the customer and you guys can know when it's going to be time to get more storage. So again, here's some of that chart I was referring to earlier, looking at my read-write, my block size here, and then over here looking at 100% reads. Again, very small difference between my 2K and my 8K, and not a lot of difference even between my 8K and my 16K. So again, for a lot of the workloads, we don't see a lot of performance difference. Obviously, as I'm getting to larger block sizes, I see a much different number of IOPS. But I don't have bandwidth listed here. I'd see a much higher bandwidth number because I'm dealing with larger blocks. And again, the bottom point, utilize Disk Magic, or have the account teams utilize Disk Magic to make sure we get as good as possible look at the workload, model that effectively against the particular hardware. And these numbers, as I show up at the top, are 1201 numbers, so I would expect the actual numbers to be a little bit better. I've not seen this chart repeated for the 12003 code. I will ask for a repeat of the 12.1 code, and sometime soon we'll give you a 12.1 update, because there are features and functions as well as performance changes in the 12.1 code. So again, I'm not sure what you guys are going to be seeing, but I have options in the 9000 and the 9000R. I have what I call based on my default option, which is 16 gig fiber channel and 10 gig iSCSI, and I also have an all iSCSI option. And I believe the ones that were specified are the combined ones. And what we're seeing there, I see this on the A9 like we saw it on the XIV. For the most part, customers are still using fiber channel for host IO. Now we're seeing iSCSI start to grow a little bit. And again, you guys have the IP Hyperstar offering based on the Gen 3 stuff that is all an iSCSI offering. But I'm seeing for the most part, the customers are using fiber channel for host connectivity and then the iSCSI for replication connectivity. And again, just to hit on the point, the best practice is to have at least one connection to each grid controller, and I'll show you that in a little bit. So moving to zoning, and for the pod or the A9000, it's pretty simple. I'm going to assume a dual-ported host, and I'm going to assume 6 paths. My A fabric will be the ports 1. My B fabric will be the ports 3. I specify as best practice I use ports 1 and 3 for host connectivity and don't use ports 2 and 4. I save those for replication or migration connectivity. Do have some customers that have multiple, more than the 2 fabric design. So sometimes I've got customers that are either not doing replication and therefore don't need 2 and 4 for replication, or using the 10 gig iSCSI for replication. So I have fabric A, fabric B, fabric C, and fabric D. But as you can, and again on a 9000 that's manageable, but you talk about a full up A9000R with 12 grid controllers and 48 ports total. 48 paths is just too many. Right? Even 24, which is cutting that in half, is still too many. So when we go to the A9000R, we've got a modified best practice for a zoning perspective, and I think I've got this all pictured right. So here is showing half the paths. So I've got in this box, I'm again zooming full up, 12 grid controllers. I want every host to see every grid controller. But because I have 2 paths on each grid controller for host I/O, I don't want this host to see 24 paths. I only want it to see 12 paths. So I've got half the picture here. Half the picture is for half of my hosts, I go through switch A and pick up modules 7 through 12, port 1, and they pick up modules 1 through 6, port 3. So I've got redundancy. Even if I lose a fabric, I haven't lost all of my paths. I've only lost half of my paths. And then for the other set of hosts, the other half of the hosts, I flip that picture. All right, so the host is going to see then through switch A, it's going to see ports 1 through 6 on port 1, and then on switch B, it'll see module 7 through 12 on port 3. So again, I'm assuming with these pictures that the A fabric is all hooked to port 1, and the B fabric is all hooked to port 3, and then by utilizing zoning on these, I'm minimizing the number of paths that each host sees down to 12. Again, that's a full-up box. As we go forward, again, looking at things, here's my 12 paths. For a 5-grid element, I'm going to suggest 10 paths, again, using that same alternating sequence. For the 4-grid, again, 8. For you, again, if we go to a 3-grid, there's some discussion there. If the customer isn't going to grow past 3-grid elements, then 12 paths is probably okay. If they're going to grow, or again, there's especially if they're in a VMware environment where we can have a issue with number of volumes, number of paths on a per cluster basis, then maybe doing 6 is the right thing to do. Again, I would do half and half so that so every host sees every grid controller. They just only see, half the paths, not all the paths to the grid controller. And for the 2-grid element, again, I suggest going to 8 paths. Again, the same sort of I would be using ports 1 and 3 for each host in that case, but I do want to maximize the number of paths to make sure I'm getting good use out of my multipathing algorithm in that case. But anything bigger than that, I'm okay with only 1 path per grid controller per host on each fabric. Again, assuming a dual fabric host. So that's it from a performance perspective. I'll go ahead and pause here real quick and see if there are any questions. All right, so I've only got 1 slide on monitoring, and then we're going to switch over to the GUI and poke around a little bit. So a couple things, right? There's a huge set of events, right? They are available. So I'm doing 2 things. I'm sending them, assuming the box is set up properly. I'm sending them to the event center where they are saved and managed, and by the automation at the event center, and then also with the help of level 1 and level 2, if the event center needs human intervention. But that same, so a subset of those events are available to the customer, to the administrator. I say a subset because there are certain events that go to the event center that are internal events that are not surfaced up through the events that you see and are not surfaced through the email, SNMP, or the text message via the gateway that the box has available to it. So there's a superset that goes to the call home or calls to the event center, and a subset that's available to the admin or the folks monitoring the box. One thing that is available is I've got the GUI snapshot up here from the GUI is for my pool thresholds, I can set a system level where I'll get warnings at certain things, and then we're looking at the defaults here. The default is only 3, right? 80, 90, and 95 for warning, minor, and major. I can obviously set those and add informational and critical. In fact, I kind of suggest that you do that, is at least add critical and go to 4 levels and then have, 75, 80, 90, and 95, as opposed to just the 80, 90, 95. Sometimes even for warning, I'll set it to 80. I'll set warning to 70, minor to 80, major to 90, and critical to 95. So I've got a bigger gap between between warning and minor, minor and major, and then a smaller gap between major and critical. Because obviously I don't want as much time to go by if I'm already over 90% before and getting the 95% before I again warn somebody and hopefully some action is taken. But I can do a custom one on a pool basis, or I can just leave it at the system. For most cases, because the A9000 monitors and manages the kind of the virtual capacity behind the curtain, setting them to the 4 different levels and leaving that set for the whole system is typically adequate. And then the other thing we'll talk about, and we'll look at it and we'll do, is performance monitoring. What we want to do, rather than just talk about it, is go to my GUI. There. Karen, are you seeing the GUI now?
Yep.
All right, cool. There's a lot.
Hey, Steve?
Yes.
I'm sorry to interrupt you. This is Rhonda. I had a question, but keyboard challenged. Anyway, I kept hitting the wrong mute thing. But anyway, I've been getting a lot of, I've been approached about A9000s being deployed on our SO accounts, and we have yet to get those best practices together. And I just wondered, with all this good information you have, that perhaps you have some guidance that, is it just in these charts, or perhaps you got a best practice kind of document yourself. Do you have anything like that the teams could use?
We put some in the Red Book. Brian Sherman and I are co-authors of the SVC and A9000, or SVC and Accelerate Best Practices. I'm not aware of a separate, just A9000 Best Practices document. Like I said, we put some in the Red Book, and I've got the specific stuff for SVC in another red paper.
Okay. Okay.
But I'd be more than happy to give you. I don't know whether you do yours in a doc or a presentation, but I'd be more than happy to. You'll have these charts. I can give you others, and please, if you need another set of eyes, I can actually put that in front of my whole team and have them review any docs that you create. So you've got a number of folks with lots of field experience looking at it and make sure we catch everything we need to catch.
Yeah, I figured you'd say that. You've been so helpful. Some of these new accounts that are getting these, they may have some config questions and such. So
yep.
They may reach out. So I just wanted to give you that. And we do have to work on getting, a pre-go live and then the best practice doc. So that's some stuff.
And I'll make the offer to Jim. I'll make the offer to you as well. Even if you think you need some help with config, on-site help with config for some of the early customers, just to make sure we're doing it right, that's something we can certainly look at giving you guys a hand with.
Oh, thank you. Okay. Well, thank you.
Yeah, that's the beauty of the role I have. If there's a customer at the other end anywhere in the world, they're one of my customers.
Okay, well, you said that now, so be prepared. No.
Thank you. It won't be any different from the floodgates that opened years ago, Rhonda.
Okay, well, thank you much. And
you're welcome.
Thanks. Bye.
So I'm looking here at the capacity, right? And I've got some warnings here that have come up. I think I've got a pool that's full. Again, for a VVol service, that's actually expected. I'm not worried about that. I've got one of the pools on the A9. The snapshot is above a threshold, so I'm getting a warning there. Now, I'll also get events for this, but the nice thing about the dashboard is They're surfaced right here where I can see them right up front. Hardware, again, I think I've got a failed drive. And then for connectivity and security, I've got I got a couple hosts in this environment that only have single path. So again, for production, that's really bad. For a demo lab environment, we live with it. The other thing I want to show you guys is I can come in here, close that, and I can change some things about this health configuration. I can, in general, scroll down a little bit here. Oops, too much. Here is the health reduction for each of the levels of severity, so I can change that if I want to. I could bring a critical down. I could bring a major up, so I would kind of change the difference between a major and a critical. But again, I can change that on a per HSM basis. So again, I am configuring this particular hyperscale manager at this point in time, but I can do that. I can also come down here, right? And if there's certain things I don't want to show, like I don't care. Again, I'm in a test dev environment. I don't care about host connectivity. I can say don't show the tip. So there's some ability to configure some things and change what surfaces in that dashboard by coming in here and doing this. I'm going to go back to the dashboard now. And also, just kind of to highlight, I'm managing not only the 9000, but I've also got an XIV and I've also got a Spectrum Accelerate. So I have the ability to manage all of these devices through a single pane of glass now. And the XIV, again, we still got some Gen 2s out there on production floors. It does not support the Gen 2, only the Gen 3. But I think for you guys, the majority of what you've got out there are Gen 3s. So there, again, there's just some overall monitoring. Also looking here, I'm looking at my dedupe ratio, my compression ratio, my overall reduction savings. If I come to system, I can look at system info. So I have, again, number of mirrored volumes, number of map volumes, how many domains I have, my QoS limitations, and I can also look here at efficiency and look at my reduction savings as well as my thin provision savings, and then my total efficiency. Now, this is the 5.1.1 GUI. Some of this changes in the 5.2 GUI, which, again, will come out with the 12.1 code in now June. But let's just take a look at the Flash System 9000. So here I only have one, so I'm getting a much clearer picture now of what's going on with just the 9000. I'm obviously getting better reduction savings overall because I'm getting, dedupe as well as compression, and I'm only looking at the 9000. I also have only that one error about the pool has stayed with me, right? So I've still got the same problem or potential issue with my snap capacity in that pool, but now that's the only thing I'm seeing because all of the other issues were affecting the XIV or the Spectrum Accelerate. Now here is a change that is different from 5.0 to 5.1. I believe it stays about the same in 5.2, but it does change a little bit. Projected system capacity. So we don't use the term effective capacity or effective system capacity in the GUI anymore. I believe the marketing documentation still uses effective capacity. But let's go ahead and change the ratios and see what comes up here. So and I went through and changed this to 4.5. I've got a starting point is my physical capacity, my usable capacity, the projected reduction ratio, and then I've got the ability to use that as a fixed size, or the default is to use it in combination with a dynamic algorithm, and I'll scroll down here a little bit. And that dynamic algorithm essentially says, I'm going to take what I have written and use the actual data reduction ratio for what I've written, and then also change, and then look at how much capacity is left over, and then take this, hang on, I'm going to go up a little bit more, then take this projected ratio and use that to project what's going to happen to the system. So the problem that can occur here is this is defaulted to 5.0. If your customer is getting, 4 dot something or better, the projected system capacity is going to be pretty close to accurate. But let's say, and I'll just change it here, let's say they're only getting 3.5 or 3.2. I'm going to change this to 3, and you see that the very large change in the projected system capacity. Partly because I've not written a lot to this box, so I'm projecting more than I'm using the actual numbers. But that's something to watch. And as we write data to the box and we see what the data reduction ratio is, we probably want to go in and change this to be closer to what the actual ratio is, so that the projected system capacity is a more accurate determination of what they were going to get out of the box. So the one change that's coming to 5.2 is I'm able now to say, and basically just use the actual data reduction ratio to project the capacity for the entire box. So I'm not going to combine it with an algorithm. I'm not going to have it fixed. I'll have the option to say, hey, just use my actual data reduction ratio to create my projected system capacity. To me, that's a better choice. However, there's a caveat there. As I am loading workload onto a box, if I've got a wide variety of data that's coming onto the box, my projected system capacity is going to fluctuate and could fluctuate wildly as I get that different workload onto the box. And once it's all on there, and then I'm adding workload as the workload grows, or moving a smaller number of workloads onto the box, I won't see, and obviously the more data I have, the less likely my average is to change. So there can be some consternation at the beginning because the projected system capacity is fluctuating wildly, and that is the downside of going to the fixed only. But again, I wanted to show you guys what we've got and what the options are, so you can, again, do what's best for your particular environment. So I want to look at, look on systems. I want to look I can look at alerts. All right, it brings up what the alerts I've got. Again, some of these we already saw based on some of the things we were looking at. I can also look at all of my events. And I've got the ability to do only my accelerate, only my flash system, all of my XIVs. Now here I've got one flash system. If I've got multiple flash systems, I can come in here and look for things, the different event codes, different descriptions, and I can monitor the filter to change what I see. This is probably a good one, event minimum severity. Right, and I want to look at anything that's minor or better. I don't care about warnings or informational. Also, there we go. Also, when I have the ability, right, to send these events to my email or to someone else's email. Again, looking at major and critical in an email is probably the right thing to do, because if not, the box, especially at initial setup time when I'm creating pools and creating volumes and creating users and all that, you can flood an inbox with hundreds of messages. All right, if I'm creating 100 volumes or 1,000 volumes, I'm going to get 1,000 messages, one on each volume creation. So again, if I cut that down and only do major and critical, I'm only going to see the things that really need attention. And I believe you guys have a system set up where you've got an SNMP catcher, and obviously everything will go to the catcher, and we can then write rules on the catcher to bring other things to folks' attention if we need to. But lots of good capability here. Just you can, again, overwhelm your inbox. And I don't know about you guys, but I know I've got enough stuff in my inbox without adding stuff I just have to delete anyway. So there's events. And then the next thing I want to look at is performance monitoring, so statistic views. I can look at lots of different things. I can look at host history and forecast. I can look at system capacity. I can look at performance classes, my QS classes, look at performance there. I can look at host level. I can also look at a volume level, as well as a system level. Let's take a look at volume stats. So what the GUI does is it brings in the most number of windows you can. I think I can, if I go to a higher resolution, I can go to 3, but 2 or 1 is typical based on the resolution of the screen. And right now you can see these are volume stats. It's all interfaces. And I'm looking at, by default, I look at IOPS and latency. So the box is not super heavily busy, right? It's only doing 20,000 so IOPS, which for a flash system is nothing. And it's doing, let's call it average 250 microseconds, or between 0.2 and 0.25 milliseconds. So as I'm mousing over, you can also see I also get my min and my max. So it's obviously I'm not doing anything on my open stack stuff. We're not doing much, and I'm doing more in my test data store and both test data store, so I can see my maximum volumes there. Now the funny thing is, if I look down at my I'm looking at latency. If I look at IOPS, it's a different story. I'm doing my maximum IOPS on my OpenStack volumes, and I'm getting my minimum latency on my OpenStack volumes. Again, not unexpected, because a volume that's not doing much work, it's probably not going to have information in cache, so my latency is going to be higher on that because I'm not doing much. So I'm destaging whatever in that volume to make room for my active workload and keeping that in cache. So again, I can get my good cache hit ratio on the volumes that are doing a lot of work. So I can come here and click on this volume, and I've just changed from looking at all of my volumes to looking at that particular volume. Again, I've got my IOPS and my latency view. The other thing I can do is change here from current to historic, and then I actually see I've got lots of other choices. I'm looking at all interfaces. Here's my historic IOPS. I can look at read, write, or read plus write, or so I can separate my reads and my writes. I can look at hits and misses. I can look at a variety of block sizes, and I can also look at a range. So let me go ahead and let's look at the last day for this volume. And you can see I asked Chris at the briefing center to crank up I/O just before we got on the call. So we're just getting started. Let me come up here to this other chart and also go from current to, let me go to historic IOPS. I want to do it this way. So now I'm looking at a different time frame here, but what I want to do here is separate this out. I'm going to come up here and look at my read data up here. I'm going to come down here and look at my write data down here. I'm going to change the range to be today. And then I'm going to lock these, the two charts to keep them locked. So I can scroll, I can change the range, and it'll keep these charts locked. So you can see what I'm looking at here is I'm looking at a complete read workload. Right? I'm getting absolutely nothing on the right side for that volume, and I'm seeing everything I can on the read. So I've got the opportunity. I can also, if I wanted to, I can look at different interfaces. The next release, I'll actually be able to specify down to the port level. Now, I'm saving that information. It is saved in the box, but I don't yet have the ability to surface it in the GUI. I can obviously do use the CLI command and export that content and put it in a spreadsheet or something and look at it. But again, with the next release, I'll have the ability to look at down to a port level inside the GUI. So it looks like I've got about just about 7 minutes left. What I want to do again is pause here and ask for questions, and I'll make it fair game for anything we've covered in the 4 sessions so far, or anything that you think we should have covered and haven't yet. So that feedback on what you think needs to be covered would be valuable, because we can certainly, as we keep doing updates on this, like I said, I'm working on when we're going to do a 12.1 update. We can certainly add some stuff and cover more topics as we're doing the 12.1 update. So it's your guys' time for the next 6-7 minutes. What you got for me?
Stephen, hey, my name is Chip. I don't know if I interrupted somebody. I'll go back off if I did.
No, go ahead. Chip, you're up.
Okay. All right. Currently, I support Michelin North America, which is building a new data center. We have 3 A9000 150s that have been installed there. We have not configured them, nor we have provided any type of provisioning for them on the initial basis. I have 3 questions. I don't know whether or not you have time for even one of them, but I'm just going to throw them out.
Okay.
Is there any value in adding Easy Tier to a 100% flash device?
Probably not if that's the only device.
Okay. My second one would be, is there any advantage in creating different pools, say one for AIX provisioning and another one for ESX or VMware provisioning?
From a performance perspective, no. A pool is just a logical construct. From a management perspective, yes, because it allows me to look at volume size and growth at a more granular level.
Okay. The last question is that the A9000, is it supported by VSC? That would be the old TPC. And if yes, can you tell me if the stats generated by VSC are similar to the stats that you would see under Hyperscale Manager?
So, sort of, yes. It's supported. I say sort of because I just saw some node streams that there's some errors that are going to be fixed in the 5.2. I want to say 5.2.1.6, but don't quote me on the version. But there are some things that are being changed in the in spectrum control, right, which is the basis for both of those, if I'm remembering correctly. But there also have been changes in the 12.1 code, which are essentially making them do some more changes to the control code. So yes, it is supported. One of the things they're fixing is there's an error in what's reported in control, where it's reported accurately in the HSM or the GUI here. but I'll also say it's kind of a moving target in that we've been changing how we report data reduction from the A9000 perspective, and that has forced the control guys to go through some gyrations to kind of keep up with us. I expect we're done with that now with the 12.1 release and the 5.2 code that's coming out in June. So I would hope that we give the control guys a chance to get completely caught up and make everything right.
Very good. Thank you. One more thing is that would you be amenable to an invite between my chief engineer and myself on some initial conversations before we actually go forward?
Absolutely, be happy to help, and if I can't, I'll get somebody else from my team who can.
Thank you so much.
Okay, Steve, this is Tony.
Hi, Tony.
How are you?
I'm doing great.
When you are doing the health configuration and you are able to change it in flight, can anybody do that? Can any user that log into the management tool do that? Or is there a particular...
So any user that has storage admin privileges can do that. If they don't have storage admin privileges, if they're read-only or an application, oh, wait a second. So I don't think application admin exists anymore. So if, any storage admin can, but if they're read-only, obviously they can't.
Okay. Thank you.
Got a couple minutes, folks. Anything else? All right. Well,
if you need to ask a question.
Hey, this is Michael Ray. I got a question. And I haven't been able to make all the calls. Is there any documentation that shows how the A9000R compares to like the EMC counterpart, like the Extreme IO and other devices like that?
Yeah, we've actually got a competitive wiki out there with information on the A9 and A9R against a bunch of the competitors. I don't use it a whole lot, but I know it's out there. If you need it, I can help you find it.
Thank you.
Steve?
Yes.
This is Ramesh here. I just would like to know how many pairs of volumes is possible through Metro Mirror or Global Mirror?
Okay, so my total volume count on the A9 is still 15. My total replication count, is 1536. So, and we don't use Metro and Global on the A9. I'm not sure why. Well, we don't. We use sync and async. So I can have 1536 synchronous replication relationships between one box and up to 10 other boxes. From an async perspective, each async counts as 3. So my maximum async count should be 512, right? 1536 divided by 3. However, with the 1203 code, there is a further limitation on replication, async replication to 200 replication pairs. I expect that restriction to be lifted with the 12.1 code, but I have not yet been able to get confirmation that limitation will go all the way back up to 512. That was the kind of the design requirement that we gave the development team. I have not seen confirmation that they were able to achieve that goal. So I expect it to go to 512, but it may actually only go up to some number between 200 and 512. And then just to give you a kind of a view further out, later on this year, I do expect those overall numbers to go up yet again, because I know that's been a question that Jim has had, both on the XIV and the A9, that he needs more replication pairs. I know he's been really active with the development team in trying to make that happen.
Thank you.
So kind of to finish the answer there, if I've got a mix of sync and async on any given device, which is supported, right, async counts as 3 and synchronous counts as 1. So just subtract that from the 1536 and you'll know how many total relationships you can have on any given box.
Got it. Thank you so much.
You're welcome. All right, we're past time. I'll keep answering questions if they keep coming up, but I just want to thank you guys for your questions and your attendance. And any more questions before we close the call? All right. Well, my name is on all of the presentations. I'm assuming you guys all have access to Blue Pages. You can find me and send me an email or send me a same time. If something really urgent comes up and you don't get an answer from me via email, again, find me via same time, or maybe send it up through, I don't know how you guys get to Jim and his team. I do travel quite a bit, so if something urgent comes up and you're not getting an answer from me, you may want to go to alternate sources. I'll answer them as fast as I can, but sometimes I'm just so busy with customers on the road that I don't have time to get to email. I think that's it, Karen.
Steve, thank you so much. All right,
My
everyone,
pleasure.
have a great afternoon.